This slide is about the relationship between upthrust and the weight of the displaced liquid. Before starting this topic, you need to understand one thing. If we multiply density of a person, just for example, if we multiply density of teacher with, no, 1 second. If we multiply density of wood with volume of, for example, a person, say teacher, then it is the mass of the teacher, if he is made of wood, if he's made of that certain wood. Basically, this concept is used if you want to estimate the weight or the mass of an object. If it is made of a different material, then the method is that you should take, for example, let's take, we want to make a statue of, for example, some actor made of copper. We want to make the statue of an actor, any actor made of copper, and we have to make this statue stand on a weaker platform, on a weaker sporting material, which can be broken. And here the weight of the statue is just, for example, important. How will you calculate that weight theoretically? The method is that if we multiply the density, of copper to the volume of the actor, if we multiply density of copper to the volume of the actor, then it would give the mass of the statue of the actor of the same dimensions, mass of the statue of the actor of same dimensions, if the statue is made of copper. So here what we understand is that if we multiply density of an object X with the volume of an object Y, then we get mass of Y if it is made of X. Now here we get the final formula for upthrust that we achieved was, it was density of the liquid into acceleration due to gravity into area of the object into length of the object that is immersed. So upthrust can also be written as the density of the liquid into acceleration due to gravity into volume of the object that is immersed. Here one thing is important. If we multiply the immersed volume, one important factor here that we need to understand is that immersed volume is generally equal to the volume of the object. But one more important thing is that the volume of the immersed object the volume of the immersed object will be same as the volume of the displaced liquid. Now, if you go back to your O level, you remember that you use this concept to find the volume of irregularly shaped objects. When you have to find the volume of an irregularly shaped object, you dip it in water and you use the concept the volume of the liquid displaced is equal to the volume of the object that is immersed. So volume of the object immersed will always be equal to the volume of displaced liquid. So this formula could also be written as, when we write upthrust, upthrust is equal to density of the liquid into G into volume of the displaced liquid, then we need to understand another situation in which we can call density of liquid if it is multiplied with volume of displaced liquid. It gives you the mass of the displaced liquid. So the final form of this formula will become, you see, if we write upthrust is equal to G times density of the liquid into volume of the displaced liquid, which finally will become G times mass of the displaced liquid. And you know, M into G will be the weight. So this would become the weight of the displaced liquid. So if we multiply mass of the displaced liquid with the acceleration due to gravity, this will give us the weight of the displaced liquid. So basically it is the weight of the displaced liquid that becomes, that becomes the upthrust. So upthrust is equal to weight of the displaced liquid basically. Now another important topic here is an object will sink or it will float. To understand this, you have to compare two forces. When an object is dipped in water, there are two forces on the object. One of them is the weight of the object, and the other force is the upthrust. Now, a simple method to understand this is if upthrust is greater than the weight, then the object will float. Yet, if the upthrust is less than the weight, then the object will sink. And to further understand that, if we write upthrust, if we break upthrust into basic terms, then we know that upthrust was equal to the density of the liquid into G into volume of the object. And on the other hand, the weight of the object was equal to the density of the material of the object into acceleration due to gravity into volume of the object. Now, if we write this decomposed form of the weight and the upthrust, then this gives an important comparison. Like there are two forces on the object. One of them is the upthrust, which is equal to density of the liquid, G, and into volume of the object. And then the other force is density of the object, G, and volume of the object. This is upthrust, which is basically equal to the weight of the displaced liquid, and this is the weight of the object. Now, if we write condition for sinking and floating, then from here on we can get if density of liquid into G into volume of object, that is upthrust, is greater than density of the object into G into volume of the object, then you see on the two sides you get G and you get volume of the object. As a result, it only depends on the density of the liquid and the density of the object. So this is the condition 2. It will float. So it's all about density after all. So if density of liquid is responsible for more upthrust. If density of liquid is greater than the upthrust, if the density of the liquid is greater than the density of the object, is greater than the density of the object, then the object must float, and it's other way around as well. For example, if we get a situation where if mg of the object is greater than the upthrust, which will give us density of the object, G into volume of the object is greater than density of the liquid into G into volume of the object. This is the weight of the displaced liquid, and this is the weight of the object. In this comparison, we have G on both sides, volume of object on both sides. So if density of object is greater than the density of liquid, then the object will sink. So sinking or floating in case of ships, boats, and many other applications, in case of submarines, ships, and boats, these factors are very important. For the movement of submarine upwards and downwards, we have to change its density by filling or removing air or some other techniques. So it's all about density. then the object will sink. So sinking or floating, sinking or floating depends on the comparison, depends on the comparison of the density of the object and the density of the fluid or the liquid and nothing else. So the shape of the object, the size of the object, nothing will decide whether the object will sink or it will float. It is only decided by a comparison of the density. If the density of the liquid is greater, then the object will float, and if the density of the object is greater, then it will sink. So this is the second class of the upthrust. In the third class, we'll discuss different factors on which upthrust depend and its variations with those factors. Take care, students. Khuda Hafiz.